continue with arc length next class. So it won't be very long. So for integration, we're going to also integrate component-wise. So the integral from AB of r of t dt, this is going to be the integral from AB of x of t dt, the integral from AB of y of t dt, and the integral from a to b of z of t dt. So as an example, let's try to integrate from 0 to pi 1 t and sine of t. So the integral 0 to pi of 1 t and sine of t. Okay, so this is going to be equal to, so again, we can put the integral inside, take the integral of each component. So it's the same as the integral from 0 to pi, well, 0 to pi of t, t squared over 2, and negative cosine of t. Good, so then this is going to be equal to pi squared over 2, and cosine of pi minus cosine of 0. Yeah, pi, yeah. Okay, perfect. Any questions about this? So, so again, like in Calc 1, we have a constant that shows up. So the integral of r of t, if you don't have bounds for your integration, dt, then this is going to be r of t, where the derivative, okay, 1 second, plus some c, where r prime of t is equal to r of t. Okay. So let's, so going back to the previous integration, if we did not have bounds over here, so if we were just integrating, the integral of 1 t and sine of t, then we would get t plus c1, t squared over 2 plus c2, and negative cosine of t plus c3. So you would get constants. Okay, so now they ask us to, so they tell us the path of a particle satisfies this derivative over here. So that's its velocity at different points. And they ask us to find the particle's location at t is equal to 4 if r of 0 is equal to 4, 1. And this always helps us find the constants. And so all we have to do is integrate this or find the antiderivatives of that and then find what the constants are. So let's first write down what that is. So we had 1 minus 6 sine of 3t, 1 minus 6 sine of 3t. And 1 over 5t, 1 over 5t. Okay, so, and this is dr over dt. So r of t is going to be, well, let's find the antiderivative of this. So that's t minus, okay, plus 2 cosine of 3t. Right, take the derivative of this, we get 1, and then the 3 comes out, gets us 6, the cosine becomes negative sine. Okay, and then this would be 1 over 10 t squared. Oh, sorry. 1 second, I need to answer an important text. Sorry about this. Okay. Sorry. So this. Okay. So it was this plus C1, comma, 1 over 10t squared plus C2. Okay. Now R of 0, we're told that that is equal to 4 and 1. All right. Yeah, 4 and 1. That's R of 0. Okay, and that's equal. Now, if you plug a 0 into your t over here, what you're going to get is you're going to get 0 over here. So you're going to get 2 times cosine of 0 plus C1 okay, that's this side is equal to 4. And well, yeah, that's equal to 4. So let me actually not do this. Let me just write comma. And then the other thing that we get is that this side, and so this is 0, so C2 is equal to 1 because this over here is 0. Okay, so that tells us that this is 2, so negative. So C1 is equal to 2 and C2 is equal to 1. So let's plug that into this equation over here. So that tells us that R of t is going to be equal to t plus 2 cosine of 3t plus 2, comma, 1 over 10t squared plus, 1 second, C1, it was 2, yeah, C2, 1, plus 1, right? C2, yeah. Okay, so now they want to know what R4 is. So R4 is going to be, so the particle at time 4 is going to be a 4 plus 2 cosine of 3 times 4 plus 2, 1/10 4 squared plus 1. So yeah, again, quick review. They give us the derivative, they give us the point, and they ask us to find the location of the particles t is equal to 4. So we take the antiderivative. We have that the antiderivative is this. So t plus 2 cosine of 3t, 1 over t squared, plus 2, 1 from your constants, and R4 is equal to that. Perfect. Any questions about this? Is it clear?
Yes.
Okay, so now we have very similar formulas to the fundamental theorem of calculus that we had from Calc 1. So the integral from AB of R of t dt. So that's going to be equal to R of B minus R of A, where R prime of t is equal to R of t. And we also have this formula that the derivative of the integral, you just drop the t inside. So both of these are very similar to the fundamental theorem of calculus from Calc 1, but now you have 3 components in each place instead of 1. So going to the summary, we have the sum rule, the derivative of the sum, it goes inside. If you have a constant, it comes outside. We have the chain rule as before. We have the product rule for multiplying R of t by a scalar, and last time we saw how to prove this. We have the product rule for the dot product. We have the product rule for the cross product. We said that the derivative at some point is the tangent vector at that curve at that point. And we also said that the line at that point will be R of t0. That's the point on the line where we start, plus t of R prime of t0. And that this over here is your V. Okay. And then we had the two parts of the fundamental theorem of calculus, part 1 and part 2. Okay. Any questions about this? So we're going to stop here. Next time, we're going to continue with the arc length. So yeah, is there anything else? I posted the tests. I posted one of the videos from this section from last week online, but I did not post the second one yet. Are there any questions about anything? Okay, good. So like I said, we're going to end early because that in the syllabus, and I want both sections to go in the same pace. So the syllabus, we are up to arc length. So yeah, please also try to finish the homeworks on time. And okay, see you next time. Bye.